Hello, and welcome to the 19th Florida Keys Mosquito Control District Oxitec Public Educational Webinar. Our topic today is mosquitoes and climate change. As presenters, we have Andrea Leal, the Executive Director of the Florida Keys Mosquito Control District, Kevin Gorman, Oxitec's Chief Development Officer, and I'm Meredith Vincem, a Florida native and Oxitec's Head of Public Affairs. We began this series of public educational webinars about 2 years ago to share information with residents of the Florida Keys and provide forums to answer questions. The webinars are open to everyone. They are recorded and made available for everyone after the event, along with the materials presented. Questions relating to the webinar topics will be answered during a Q&A session at the end. We spend the first half of the webinar presenting, and then the second half, so the last 30 minutes, answering your questions. You can begin to you can begin to input your questions now or as we are presenting. You do not have to wait until the Q&A portion. You will remain anonymous. No one's going to see your questions except us, the presenters, and we will not identify you. So please feel free to go ahead and start putting questions in the Q&A box. And we just ask that the questions pertain to tonight's topic. And if you're a resident of the Keys, please list which key you live on. We will give priority to Keys residents. If time runs out, we accept questions in writing via florida@oxitec.com. And again, all questions and answers will be treated anonymously. So our agenda is global climate change and health risks, evidence for a hotter, wetter future, climate change and invasive species, impacts for mosquitoes, and then your questions answered. Hopefully you all are familiar with our project website, keysmosquitoproject.com. Documentation, resources, references, and other information are available there. Kevin, over to you.
Super, thanks Meredith. I really appreciate the introduction. Hi everybody, welcome to the webinar. I think Andrea and I are going to do a bit of a double act and we'll swap a few slides across, but I'll start. And really the objective of the webinar today is to talk about why climate change can impact mosquitoes, mosquito-borne diseases, and what relevance that has particularly to the US. So this first slide really, kind of high level, but just really is trying to emphasize that climate change is something that's on everybody's radar, of course, but big organizations, international organizations, be that WHO or others, are really predicting now that climate change is going to significantly impact health. We'll come on to vectors and vector-borne diseases shortly, but you can see from that first bullet there, 250,000 more deaths globally per year due to malnutrition, vector-borne diseases, and heat stress is predicted by the World Health Organization. And a 2019 study in PLOS NTD, a scientific journal, also predicted that by 2050, disease-carrying mosquitoes alone would ultimately threaten over 500 million more people than they do today. It's a wide subject, climate change, and there are experts who are far more versed on it than us. We are specifically thinking of this relating to vector control. There are impacts, much more broadly on human health than just vector-borne diseases, of course, and that might be food or water availability, but it could be air pollution or other aspects. It's certainly a subject that's very emotive. It's one that most large agencies, organizations now really concede that it's real, it's happening, and mitigation is required. NASA, another large organization, has also looked at modeling, an organization that is pretty good at modeling, I would suggest. And they're predicting, along with hotter and in some places, drier conditions, many places will actually suffer from much wetter conditions. They're predicting that flood risk will be much higher in coastal regions, and particularly when we're thinking about the Florida Keys, the rise of seawaters is a particular issue, of course, as with many other places in the world. More intense rainfall, more intense storms that are more frequent, storms that are more likely to be damaging when they do occur. These are all things that are predicted to happen with global warming. It's not just about places getting drier and hotter. It's also about places becoming much more wet and much more extreme at both ends of the scale. Of course, there will be places that do come into the zone, if you like, for insects like Aedes aegypti, and there'll be others that are actually sort of moving out of the zone. But for the US in particular, where most of the mosquitoes, certainly the disease-carrying mosquitoes associated with neglected tropical diseases such as Zika, dengue, and others transmitted by Aedes, are more at the southern end, it's quite likely that we'll see a rise in prevalence of this particular mosquito. There is quite a lot of evidence for a hotter, wetter future, and I think most people are experiencing it themselves. I'm in England at the moment. We've just had, the week before last, our hottest ever recorded temperature of over 40 degrees, the first time in the UK. Meredith's in France, and Paris was suffering similar heat waves recently. This summer has been record-breaking in many places around the world: India, China, the US. Many regions seem to be having much more frequent hot and high temperatures. And in many places, that's coming out with different symptoms, be it dryness, be it rainfall, be it storms. But those temperatures are seemingly increasing all the time. Certainly some US cities, as well as in Europe this year, have reached very dangerous levels. We've seen increased numbers of deaths because of extreme heat in cities. Millions of Americans are affected, as well as people in other countries, of course. We've seen wildfires expand both in their numbers and in their frequency. And many areas are far worse than they used to be in terms of wildfires. They're a norm. They're an annual occurrence in some places now, and in Florida particularly, where hurricanes are an annual occurrence, there is a very high frequency of potentially damaging events each year. Invasive species gets us towards Aedes aegypti and the mosquitoes we really want to talk about. There are a number of invasive species, of course, and the green iguana is one in Florida. Many of these will benefit, many of these tropical or subtropical species that are invasive will benefit from warmer environments, and that'll allow them to expand their range. In the US, that's most likely for those species to be northward. But already Aedes aegypti has been expanding in the US, and we'll talk a little bit about that in the next few slides. Andrea, I will hand over to you for this next slide.
Okay, thank you, Kevin. Yeah, so as Kevin just mentioned, one of our biggest concerns is the movement of these disease vectors, specifically Aedes aegypti. And you can see on this map that Aedes aegypti did not originate in a lot of the areas that it's now found. It originated from Egypt, and we saw, about 500 years ago, its introduction into the Americas, most likely through slave trade ships. And from there, it continued to move throughout the globe and in different areas. And unfortunately, what we see with the movement of Aedes aegypti is also the spread of the diseases that it can carry. Aedes aegypti specifically can carry yellow fever, dengue fever, Zika, chikungunya, and has been implicated in a couple other diseases as well. So as this mosquito itself moves throughout the globe, we're going to continue to see those diseases increase in areas that perhaps they had never been before. Looking specifically at the U.S., Aedes aegypti is found throughout the southern region of the U.S. And this is a really interesting map, just basically showing the different climate zones that are found here in the United States. As most of you know, Monroe County is at the very tip of the state of Florida. They're in climate zone 1. So we are actually in the same climate zone as Hawaii, Guam, Puerto Rico, and the Virgin Islands. So we are in a tropical zone. And that's why you're finding a lot of the Aedes aegypti and diseases that you've seen in those tropical zones here in South Florida. Similar to the rest of the state of Florida, it's just a very warm, humid state, which really proliferates that Aedes aegypti mosquito. Aedes aegypti itself has continued to spread throughout the United States as well. We've seen introductions in California in the last decade, and once introduced there has actually spread into about 20 counties now. So as climate continues to change, we're going to see this mosquito specifically continue moving around in different areas that maybe we'd never seen it before. And unfortunately, as you see that mosquito move around, you're also going to see those diseases. What we've seen here locally, we've had dengue fever outbreaks in the Florida Keys in 2009 and 2010. We had about 100 cases in Key West. And then fast forward to 2020, a decade later, and we had just over 70 cases of dengue in Key Largo, which is on the opposite side. So basically what that's showing us is that we are getting constant disease introductions. And as long as we have the mosquitoes here locally, we're going to potentially see those diseases establishing in our local population. Some of the big concerns when it comes to Aedes aegypti are we are seeing quite a bit of resistance to a lot of the products that we've used in mosquito control historically. So, if you add all of that together, you've got, a population that's expanding, and that population is not as susceptible to pesticides as we've seen historically. We could potentially have quite a few issues on our hands here, especially in the southern United States. And I'll go ahead and turn that back over to Kevin now.
Thanks, Andrea. Really appreciate that. So I'll talk a little bit about vectors specifically, and virtually all vector-borne diseases do have a climatic dimension to them. There are a number of ways in which the climate can affect those vectors of diseases. As Andrea's described, we can see that Aedes aegypti specifically is moving across the US and invading new counties, over 20 in California since 2013 when it was first introduced. More places do become, the different ways that climate affects vectors. First of all, more places become suitable for those vectors. That's the key. That's the key thing in terms of geography and range, host range for these mosquitoes. And Aedes aegypti is an invasive mosquito anyway, and doesn't need to be asked twice to come into a suitable area. Those warmer temperatures increase the geographic spread, and that's not just for mosquitoes. That's potentially for ticks and other vectors too. Increased rainfall can increase the amount of standing water. That creates lots more breeding sites. That means that you could potentially have a higher abundance in places where they already exist, as well as having them existing in new places. Amazingly enough as well, droughts can also support breeding by forming pools of water where Aedes aegypti and others can lay their eggs. And then as those eggs rise, as the water rises and hatches those eggs, you can get a real abundance of mosquitoes coming out. Another way is that warmer climates extend the disease transmission season for these mosquitoes. The transmission cycle of the virus within the mosquito can speed up. So that means that more females can be more infectious, and the climatic and environmental conditions of those transmission for any disease, for many of those diseases, can improve under those warmer conditions. For somewhere like Florida, that may mean where the seasonality at the moment is fairly strong. I mean, it's year-round populations of Aedes aegypti, but there is still reasonably strong seasonality. It may mean that during the winter months, the abundance of this mosquito is much higher than previously observed, and those populations become more year-round. And even for other areas, that might become the norm. Another way in which climate and climate change can impact vectors is the behavior of those vectors. Those vectors may behave differently under different conditions. They can be out at different times of the day. They can be biting more often, biting more frequently, or exposed to people more frequently. This obviously can reduce the effectiveness of control attempts. It can reduce. It can change the way people need to respond to this increase in abundance. So, changes in climate can affect vectors in various ways, and most of those are predicted to push the abundance up and to push the geographic range of species like Aedes aegypti further northwards in the US. We mentioned it before with the WHO statement, and also that publication of half a million people being exposed by 2050. There are others that say that maybe it's 1 billion extra by the end of the century, or several billion. It certainly is that most modeling aligns on very dramatically increased exposure to vector-borne diseases in many areas of the world. As I mentioned, mosquitoes aren't the only concerning vector. There are others too, and ticks being one of those. But Aedes aegypti is particularly adept at moving into new environments, and when it's associated with people so closely as Aedes aegypti is, there really is a recipe for disaster, if you like, if climatic conditions were to go too high and urbanization too far. I'm going to move to the next slide, and this one just mentions something that I think is less understood, and this is about mosquito hosts. Climate change can really affect mosquito hosts as well as mosquitoes themselves, and by hosts we mean things that animals that are required to supply protein for female mosquitoes to lay viable eggs. Hosts being the blood-feeding host of a mosquito, of a female mosquito, and clearly the recipient of a disease that's transmitted by a mosquito from person to person, from animal to person, or from animal to animal. Many birds, particularly, for different mosquitoes, but many birds are reservoirs for mosquito-borne diseases, and the same can be said of small mammals too. And it really is not so well understood quite how these populations will change, but this might have a dramatic effect on the potential populations of these particular mosquitoes, including Aedes aegypti. I briefly touched on it before, but urbanization is another key aspect for Aedes aegypti prevalence because of its association with humans. Aedes aegypti, prefers humans as its host. Sometimes it exclusively feeds on humans, and it's always in and around our homes. It's a part of life in many areas of the world, but mainly in cities. In less urban environments, sometimes it really isn't there, and it's other mosquito species that are the main problem. So increasing urbanization and human population densities really can promote establishment of Aedes aegypti. It can provide shelter, it can provide temperatures that are warmer during the winter than there would be outside at other times of the year. So that relationship between Aedes aegypti and humans really can promote its spread as well as the climate itself. And finally, I guess I'd like to talk a little bit about the Oxitec mosquito. Not too much, but just to say that, you know, it's a mosquito, the same as any other Aedes aegypti. It's exposed and to the same environment that those wild ones are when we use it. And so it can function in wherever Aedes aegypti is a pest. The 5034 mosquito can also function too. Of course, you know, it provides lots of great benefits, including potential suppression of populations over wide areas to very low levels. It's safe and doesn't come with any toxin or allergen, and it doesn't persist in the environment. However, the fact that it is operationally easy and has the ability to function where Aedes aegypti can function really gives it, you know, applicability, whether it's climates of today or climates of tomorrow. Now, I hope there's plenty of great questions that are coming in. I'm sure there are a good few. So Meredith, I'll hand back to you as we move towards the Q&A.
Thanks very much, Kevin and Andrea. We do have some questions we'll start with, and we encourage everybody in the audience, don't be shy. If there's something you're curious about, please drop your question in the Q&A box. Nobody will see it but us. We will not identify you, but do let us know if you live in the Keys, which key you live on, and we will prioritize you. Okay, so the first question, let's see, I guess this could go to Andrea or Kevin. The question is, does an increase in mosquito population guarantee an increase in disease? You might both have something to say about that. I don't know.
I can jump in first, and then Kevin, I'm sure you can add into that as well. But you know, the actual population of mosquitoes doesn't necessarily correlate with disease. You know, you have to have that disease introduction. However, we can say that the more of those vectors you have around, the better possibility that you have seeing that disease introduced. So I think that's why it's important for us at Mosquito Control to remain as proactive as possible. If we do have a vector mosquito, to make sure that we're doing our best to control it to the point that if we do have a disease introduced, we're not going to see it take a foothold in our local population.
Great answer, Andrea, and maybe not much for me to add really, but yeah, for me it's about reducing risk. So, you know, it's about the potential for threat and reducing that. As Andrea says, you know, sometimes there's plenty of mosquitoes and no sign of disease. There are some countries out there that have, you know, no more mosquitoes than others and repeatedly get hit really hard by diseases, you know, different diseases, but often from Aedes aegypti. I don't think anybody understands the true, you know, the true dynamics of each of those, and often there are some inconsistencies in those patterns, but I think it really is about reducing risk and the potential for diseases to be transmitted, and preferably preventively rather than curatively, so that it's not waiting for something to happen and having to fix a problem, but it's about nipping it in the bud, you know, before it really takes off. So yeah, for me, it's about risk management.
Thanks very much, Andrea and Kevin. Our next question, Andrea, this will go to you. And the question is there any evidence that shows an increase in ambient temperature Now, is there any evidence that shows that an increase in ambient temperature increases the biting behavior in female Aedes aegypti? So as temperatures get higher, do you also see more biting behavior from this female mosquito?
So I do know that there are some studies that have been done that have shown that warmer temperatures do increase the biting behavior of Aedes aegypti, compared to cooler temperatures. But I mean, all of these vectors have an ideal temperature in which they're going to thrive. And if that temperature goes beyond that, they're going to hang out and not go out in the daytime because they don't want to be exposed to those high temperatures to potentially dry out. But there has been some studies that have shown that warmer temperatures do increase that biting frequency.
Interesting. Thank you, Andrea. And the next question, Andrea, I think this is a good one for you too. It is, why don't we see West Nile virus in the Florida Keys?
That is an excellent question. And we have historically seen West Nile virus. We had, I think, one human case ever, and that was back in 2002. So what we think is that we're just far enough south that we're missing the overall geographical range. We're not seeing the same bird populations that you might see in other areas. We don't have the fresh water that you see in other areas where all of those potential bird hosts are congregating with those mosquito species. However, I say all of that with a grain of salt because just last year there was a West Nile virus outbreak in our county neighbor to the north in Miami-Dade. So we do see it very close to the Florida Keys, but historically we've really just never seen it in our area. It's something that we keep a close eye on. I'm not saying it's never going to happen, and of course I knock on wood whenever I speak in these types of absolutes, but we've just not really seen it here, and I think it's just due to that southern geographical range.
Great. Thank you, Andrea. The next question, Kevin, this will go to you. And the question is, will Oxitec mosquitoes work in the increased temperatures of a warmer climate?
Another good question. I kind of alluded to it earlier, really. I think, Oxitec mosquitoes, they're just normal Aedes aegypti, apart from those 2 extra proteins that they express. So, they will function wherever normal Aedes aegypti can function. As this is a product which needs to be put out there and reared in the environment, we're putting a lot of effort into making sure that this works in different environments. The difficult bit is really getting them from egg to adult, I think, for us. And we're pretty confident that we can do that across the full temperature range. Once they're out of the box and they've reared up, then they're just straightforward adults, and they're the same as the wild ones. So for us, the challenge, is to make sure that they can rear all the way through from an egg that's hatching all the way through to an adult that's emerging. And we've seen, great results in many different areas so far, and we've yet to see one where it doesn't work. So with tweaks and changes and nudges here and there, we're pretty confident that they can work anywhere that the wild mosquito can survive.
Great. Thank you, Kevin. And Andrea, this next question will go to you. The question is, does the Aedes aegypti always have to contract a disease itself in order to spread that disease? Or does it simply have to come in contact with blood from an infected individual?
So this is kind of the chicken and the egg question, which came first. But what we see here, because those diseases are not endemic is we have people that travel quite frequently, and especially here in South Florida, we've already seen 73 travel-related cases, which basically are introductions of dengue fever into the state of Florida just this year. So what we see are folks coming into our area with dengue specifically. And then, our local mosquitoes, which don't normally have dengue, will feed on those people. And then we'll see that continue from there. So already here in South Florida, like I said, we've had 73 travel-related cases, which means, folks coming in from these endemic areas. There have been quite a few that are coming in from Cuba this year. And what we've also seen is that in Miami-Dade, we've had one locally acquired case. So from those folks that were traveling with dengue, that local mosquito population in Miami-Dade fed on an infected traveler and then spread it to someone that had no travel history. So we have already seen that this year in South Florida. Here in Monroe County, we had our first travel-related case identified just last week. So it just really goes to show you that with the movement of people, you're going to continue seeing the movement of these diseases, which really shows why we need to control these mosquitoes in every way we possibly can.
Thanks, Andrea. That's really interesting. Kevin, the next question is for you. This is about the Oxitec technology. And the question is, can Oxitec use its technology during a hurricane?
Well, it's certainly something that can be deployed after a hurricane. I mean, during the hurricane itself, I think there are more important things to think about maybe. In some ways, hurricanes are relatively short-lived. And so if you're deploying before a hurricane as a preventative, then the hurricane passes, you'll be in much better shape than if you weren't. And deploying immediately after a hurricane, in a disaster hit area is really important. Hurricanes can have all sorts of impacts on vector populations, positive and negative. In some instances, they really can flush out mosquitoes and help to reduce the number of mosquitoes that are there. But in others, and many instances indeed, hurricanes have been shown to create a lot of standing water, which sometime after that hurricane can result in huge increases in mosquito abundance, depending upon species. So certainly prior and after a hurricane, a tool like Oxitec is one that really can help. And after a hurricane, often access is quite difficult. And so having a technology where it's biological and the mosquito goes out and does the searching within a specified distance, of course, can really help with application as well, because particularly if you're trying to treat lots and lots of standing water with a chemical insecticide, a larvicide, for example, that could be pretty challenging. It's challenging anyway to catch all the water, all the aquatic breeding sites. So something like Oxitec's technology, a biological approach, if you like, certainly could have its advantages post-hurricane in some areas.
Thanks very much, Kevin. Andrea, this next question is for you. And the question is, are there immunizations available for mosquito-borne disease? For example, can I get a dengue shot?
So good news and bad news. There has finally been an approved dengue vaccine. This is something that they've been working on for decades. However, that vaccine is for children that I think were previously exposed to dengue. So at this point in time, not everybody can utilize this vaccine. I'm not sure the timeline that we're looking at for this vaccine to be available to anyone or people that are traveling to endemic areas. But the good news is we're on the right track. But it just still goes to show you that mosquito control is the #1 preventative. Additionally, I know that the CDC publishes great information if you're looking at traveling to endemic countries as far as what's going on there, to make sure that you can protect yourself as much as you can as you're traveling throughout the world. But I think, we are on the right track, but we've still got a little bit of time before it's publicly available.
Yeah, and Meredith, maybe I just add, dengue is one disease, and a dengue vaccine, as Andrea says, has been something that we've been trying to get for a long time, and with varying levels of success. But there are examples like yellow fever where there are great vaccines out there which have been revolutionary in terms of their impact in controlling that particular disease. So there are success stories, certainly very good success stories when it comes to those. It is unfortunate maybe that some others haven't had vaccines developed as yet, but there's certainly potential there. But there are really, really good success stories out there like yellow fever.
Thanks a lot, Kevin. And some of you who joined our webinar, I guess it was a month or two ago, we talked about yellow fever a bit and its history in the Florida Keys. I myself have had 2 yellow fever vaccines spaced about 15 years apart. But thank you both. And we'll return to the questions. And Andrea, I'll toss this one to you, but Kevin, if you have anything to add, please do. What sort of climate change would have to take place in the Florida Keys in order for there to be an influx of other disease spreading mosquito vectors, for example, Anopheles? And yeah, Kevin, you may want to say something about that too, since we're also working with Anopheles now, but not in the Keys.
So I think that's more environment and not necessarily climate change, right? So we do see Anopheles species here in the Florida Keys, but the amount of potential breeding area, we have a very limited amount of space here in the Florida Keys. So you're not seeing those similar breeding habitats as you might see in areas that are much more vast. So I know historically we have seen malaria here, but we just aren't really seeing the vector in large enough numbers that we would anticipate seeing an issue here. I do know in, I think it was 2007, we did see locally acquired malaria in West Palm Beach, where we had a traveler that came back with malaria and went to a block party and ended up infecting, I think it was 7 or 8 folks that all attended the same party. So you can see malaria introduced here, but I just don't think we have the number of Anopheles that we necessarily would need to really see that disease take off, at least not here in the Florida Keys. And like Meredith said, I know, Kevin, you've worked very closely with that particular mosquito species and probably can provide quite a bit more insight than I can on that.
You put me on the spot, Andrea, but I think you did a great job of answering it. And sure, we are working on Anopheles abimanus, which is the one Anopheles species that has really any relevance to the US that we're working on. The others don't. Abimanus, I think, is found in the US from time to time, on occasion. But as you say, Andrea, just not in the prevalence to really sustain infections and disease transmission, long term. We're working on it for other regions primarily, and not for the US. But those regions are not far away from the US, around the Central America, Caribbean, that particular mosquito, Hispaniola, really badly affected by abimanus. And it really is a very prevalent vector of malaria there. But I think the Keys is probably fairly safe from malaria for a good while, at least from sustained transmission.
Thanks. That's really interesting, Andrea and Kevin. New information about Anopheles and malaria in Florida in recent years, new for me. The next question I mean, really, I think either one of you could answer it. This is kind of a scary one. The question is it true that dengue can actually become more severe if you get it more than once? Is there more than one type of dengue?
Andrea, I'll go first this time, and then you can supplement as required. 4 different types of dengue, are talked about. 4 different serotypes, and there was talk of a 5th some while back, but 4 different serotypes are usually mentioned, and those can cycle around. The curious thing with dengue is that protection, once you get bitten and you've been exposed to one serotype, usually you've got protection to that serotype, but you don't acquire protection to the other serotypes. So then you can get infected with one of the others, and maybe it's a phenomenon or not completely understood, at least maybe not by me, but certainly on the 2nd, 3rd, and 4th infections, the severity of that infection can typically increase, and hemorrhagic fever, complications relating to dengue tend to be more prevalent in 2nd and 3rd infections than they are in the 1st infection. So it does appear that once you've had dengue once, that you become potentially more susceptible to a serious infection from one of the other serotypes than you would have been prior to that initial infection.
Yeah, and that kind of brings it back to the whole vaccination question. Why has it taken so long to find a vaccine that works against dengue? And because there are 4 different serotypes, they had to develop a vaccine that could protect people against all 4, which really complicated things.
Thanks very much, Kevin and Andrea. Andrea, the next question is for you, and the question is, what impact does our climate zone here in the Keys have on various mosquito populations? What are examples of other countries that have the same climate zone as the Florida Keys?
So as I mentioned earlier, we're actually considered tropical. So that includes the Caribbean, that includes Central and some parts of South America as well, which are very prevalent for dengue fever, yellow fever in some areas. So that is why, our biggest concern here locally is Aedes aegypti. And that's why we see, those travel-related cases leading to locally acquired cases on occasion. So it's interesting to know that we're basically the same as Hawaii, and there's no other place in the continental United States really that's like South Florida. And I guess we probably could have, guessed that if we look at that. We are known for being a little different down here in the South, and maybe we'll blame it on the tropical climate. But it's really a climate that Aedes aegypti love, that high humidity, that heat. They can utilize every little bit of standing water that they can find, whether that's artificial containers, bromeliads, anything that can hold water down here in the Florida Keys, you're going to potentially find that particular mosquito, which is why it's so important for us to, continue to do our best to control it.
Thanks very much, Andrea. Okay, the next question, I'm interested in the answer to this one. It's, where did it go? Other than mosquitoes and iguanas, what are some examples of invasive species in the Keys?
I think that's
yeah, and that one puts me on the spot. All I can think of course, are mosquitoes. Not only Aedes aegypti, but we've seen a number of invasive mosquito species here in the recent years. Aedes albopictus is another really good example of a mosquito that was introduced in Florida, I think in the 1980s, right? And then it moved all through the area, but we didn't really see it established here in the Keys, but we do see it pop up every now and then. We've had a couple other invasive mosquito species that have popped up that we don't see in high numbers, but we go out and control to make sure that they don't establish themselves. So sorry, I just have mosquitoes on the brain when it comes to invasive species. I don't know if Kevin, you might know of any other ones. Obviously, the iguana is one that everybody is very well aware of here.
Yeah, I could have Googled while you were answering.
Pythons popped into my head just now.
Yeah, Burmese python was the only one that I could think of. Burmese python was the only one that I could think of, and
yeah, that's the other big one.
Yeah. So I'll leave it at that. I got one.
Well, I think we've just gotten input that Australian pines are invasive. There's probably lots of things there, but lots of questions. I mean, we're still getting a lot of questions about disease and about dengue. And this next one, I mean, really, Andrea or Kevin, either of you are free to have a go. If the question is, if a female Aedes aegypti bites an infected person and contracts dengue, does she in turn pass the disease on to her brood? I'm curious how a single infected person can become a string of infected people in such short order.
So if you don't mind, I'll jump in, and then Kevin, you can hop in as well. There's a lot of information with this question. So the first part is whether or not a female that is infected with dengue can pass on dengue to her offspring. And there is a very, very small percentage of what's called transovarial transmission, where she can pass that on to her eggs. But I believe it's less than 1%. And Kevin, you may know the percentage off the top of your head, but it's very rare. So when we see this disease, moving from person to person, it's most likely not because if one single female laid her eggs and those subsequent females were infected. What we see with Aedes aegypti is their feeding behavior, right? So Aedes aegypti are very flighty, right? Everyone's probably laughing at home with that pun, but they do just jump from person to person. They're not going to land on you and take a complete blood meal. They're going to probe, and all it takes is that probe to become potentially infected. So that's why you can see a very small number of infected mosquitoes spreading dengue to a large number of people. Because that female can easily go from person to person all on one single blood meal. So that's most likely what you're going to see as far as how this particular disease is spread with these mosquitoes.
Yeah, absolutely correct. And multiple bites per brood, per mating, if you like, and potentially multiple broods of eggs as well. So that can be quite a lot of feeding for one particular female. And the virus is living inside that female. It acquires it, but then the virus is replicating within the female, and she becomes very infectious. And so it really doesn't take a lot potentially to become a vector for that female. So yeah, that's that biting behavior that Andrea described is key component as to why that species can infect so many people.
Thank you both. The next question, Kevin, we'll start with you, but Andrea, if you have anything to add, please do. The question is, do hurricanes make mosquitoes more or less of a problem?
So I'd say more of a problem typically, and it's more about the aftermath. If it's a devastating hurricane, as opposed to one that's a near miss or doesn't cause so much damage. But if there's a lot of damage from a hurricane, there's a lot of potential breeding sites, increased number of breeding sites. If that hurricane comes with floodwaters as well, then certainly it can cause real trouble. So, depending upon the location, depending upon, the case by case, and there are examples where it's the other way, as I mentioned earlier. I would say the general trend is that hurricanes are worsen the situation, certainly post-hurricane.
Yeah, so my mind automatically goes to Irma, which happened recently and was quite devastating here in the Florida Keys. And what we saw at mosquito control was that initial week or so wasn't bad, but those piles of debris sitting for long periods of time collecting water definitely did add to the mosquito issue that we saw here locally. The one good thing I can say about a hurricane as far as the salt marsh mosquito goes, that we saw in 2018, one of the lowest mosquito seasons that we've seen. And it's because as all of that water washed across the Florida Keys, it washed out a lot of those mosquito eggs. So for salt marsh mosquitoes, we did see an impact on the population, actually a reduction of that population in the subsequent year. We did not see anything similar with Aedes aegypti or our other container breeders. And that is the big thing, right? So all of that debris sitting around, anything that can hold water, definitely makes our lives a lot more difficult following a hurricane.
It's really interesting. Sounds like it just depends on the species. Andrea, this next question is for you. And the question is it true there is a travel-related case of dengue in Key Largo? What does that mean?
So yes, we have had our first confirmed travel-related case of dengue in the Upper Keys. And all that means is that person traveled to an endemic country, was exposed and contracted dengue there, and then came home. Wasn't feeling well. He went to the doctor and was subsequently tested for dengue, which came back positive. The good news is that does not mean that we're seeing dengue in our local mosquito population. We work very closely with the health department. And as soon as there's a suspect case of travel-related or locally acquired case of dengue, we are out there. We know what we need to do to respond. We had a number of inspectors go through all that area, treating and dumping any standing water. I know we had trucks out in that area. We increased our adult surveillance. So because we work so closely with the health department, we can be, as reactive as possible. If we waited until we did get any sort of confirmation, usually that means we're a week or two behind. So we were alerted to this as a potential suspect case a couple of weeks ago, and it did come back as a positive travel-related case. But we're doing our best to keep that Aedes aegypti population in that area suppressed, and hopefully we don't see, any further movement of this particular disease in that area. Again, knocking on wood to get us through.
Absolutely. Thanks very much, Andrea. There's a follow-up question, and it's related to part of the answer that you were giving about the relationship between mosquito control and the health department. I guess it would be the Monroe County Department of Health when it comes to mosquito-borne disease. The question is, who tests the blood? Who tests the mosquitoes? Are there other tests?
So I believe what normally happens is, whoever that physician is, it is a reportable disease. So if that physician, whichever doctor that patient goes to, will draw the blood and will alert the health department of a suspect case. Who tests it after that? I'm sure there are certified laboratories that will handle those samples and then report back to the Department of Health. As far as testing mosquitoes go, we don't test our mosquitoes on a regular basis. But any collections that we make around potential cases or confirmed cases, we do save all those mosquitoes and potentially have the state test those for us as well. But what we found as far as testing mosquitoes go, especially when it comes to dengue, is you can collect, a large number of mosquitoes and it be very, very difficult to find that positive mosquito. It's kind of like a needle in a haystack for us. During the dengue outbreak in 2009 and 2010 in Key West, we were testing all of the mosquitoes that we collected. And of all of those samples, we only had a handful come back positive. And those were actually collected from people's homes that we already knew had dengue. So it really didn't help us out operationally. So the amount of time, energy, and money that it takes to test all those mosquito pools, we just didn't feel that it did anything as far as, assist us and new information. But we do feel it is important to, collect those mosquitoes, make sure we know where those Aedes aegypti are, and make sure those populations are controlled.
Wow, thank you. Kevin, the next question is for you. And the question is, isn't Oxitec in California, is that in some way different from the pilots in Florida?
We've applied, Oxitec have applied to extend their experimental use permit, which is currently being used in Florida, to run a pilot in California. So we've applied to do so, and we've got federal approval for that, and we are now awaiting a state decision, a state review of that application. And so we're not, officially in California with our mosquitoes yet, but we are hoping to do so. And we'd be thrilled if 2023 was that year, and we could get a pilot project going next year in Tulare County. That's where our focus is at the moment in terms of California. Very different environment, as Andrea was saying. It's not tropical like the Florida Keys. It's particularly dry at certain times of the year. It's not had Aedes aegypti for that long, only since about 2013 or so. It's spreading quite quickly there, and it's a different set of problems. There's limited disease, in that area, and none, as far as I'm aware, from Aedes aegypti. So, it is a different environment for us to work in. But when it comes to will the product work, it certainly should do. We're confident that it will. Some very extreme temperatures in certain areas of California, 40, 45, maybe even higher degrees C. So something we've not experienced in the US. We've worked in a lot of places in Brazil, in the north and in the south, and our mosquitoes have done well there. In Malaysia, our mosquitoes worked well. Again, very hot environments, but not quite as dry as California. So, we're looking forward to a great pilot next year, subject to regulatory approval. And, we're pretty confident that we can make those work just as well as they do in Florida.
Thanks a lot, Kevin. The California situation is especially interesting considering tonight's topic, because the Aedes aegypti is such a recent and unwelcome visitor, spreading to more than 20 counties in the state in just about a decade. But we have gone through our questions, and we're about a minute away from the end. So I think we will go ahead and wrap up. If any of you in the audience have a burning question that you think of later, please send it to florida@oxitec.com. We will answer it. Invite you to visit our keysmosquitoproject.com website. And hope that you will join us for our next webinar. We're having them monthly, and in August we're planning to talk about our project and how it's been going so far in 2022. But Andrea and Kevin, thanks very much.
Thank you.